So we've already covered the heck out of calculating conditional probabilities. We've done this on worksheets. We've done this in the lecture notes multiple times. But here's just some formal stuff to go along with that. Ways to know that you're dealing with a conditional probability. The biggest keyword, which I tend to use a lot so that it's super obvious, is given. If we have given, that means we know, right, that they are male. Given they are male. We know that we are in this category. These are the only people we care about. This is our whole, right, our total. And then we're looking at the event. Very happy is the thing we actually care about. So our calculation here would be the 221 out of that 325. So we have done this intuitively a ton without a formula. I'm now going to add a formula on top of that in case you needed it or in case it makes you happy. But again, you can always just tackle these questions intuitively. So knowing that it's what you're being asked for, when you're going through sentences, I highly recommend that you underline the two events. You see, oh, we got very happy, we got male, and then you look for a keyword. You're hoping to see the keywords and or because those are the easier to, in my opinion, to calculate. If you don't have an and or an or between those words, you're probably on the lookout now for something telling you that this is a conditional, a given question. So keywords that I use for given are of and if occasionally. And just keep in mind, whatever is given, of, or if is the thing we know. It's the section we would highlight. So that's what's going to go behind the line. And a big note here, this formula here is going to be given to you, both of these. Not that at this point, it doesn't look like we're coming back to school. So these formulas won't matter if they're given to you or not because you'll have them. But I do include them in a formula sheet with the exam. So these do exist as something you could be using on the formula sheet. Not that you'll need that because you'll have all of your notes at your disposal, theoretically. So those of you who always wanted a bigger note card, now you got a bigger note card. You got everything. All right, so I have an exercise here about whether or not gender influences who watches the Super Bowl. I'm just going to skip this and we're going to move on to the next page because we don't have the class time to fill that table out. So we're not even going to use that given formula yet. We're going to use the and formula in these questions potentially. But this is another formula I give to you. It's just that given formula rewritten. So given, again, this is on the formula sheet. So let's just take a moment and practice our ability to translate probabilities on this first exercise. So as I said in class, first thing you want to do is just read through the question without overthinking it. So in a sample of dog owners, 60% adopted their dogs. Of the adopted dogs, 78% were mutts. Assume 65% of all dogs are mutts. What is the probability a randomly selected dog will be adopted in a mutt? So now you're thinking, what seemed like the random variable? What were these events that they were bringing up, right? And it seems like we have a lot of talk about adopted. And it also feels like we have a lot of talk about whether or not a dog is a mutt. So use whatever letters you want. I will use the obvious letters A and M as I translate these. And also go ahead and circle all the given probabilities, all these percentages. And then we're looking for one in the end. So we can see there are 3 probabilities given to us and 1 probability that we're looking for. Okay, I'm going to go ahead and just put down the numbers 0.6, 0.78, and 0.65. I'm just translating those into decimals. You can leave them as percents. It really doesn't matter. It's just the way I've always done it. And in the first sentence, we can see nothing here about whether a dog is a mutt or not. The only thing I underlined was an A for adopted, so I'm going to just put an A inside the parentheses. The second sentence is where things get hairy. So I want you to take a moment and decide what that 78% is, because in this sentence, right, we have both mutt and adopted there. They're both there. Now the question is, what is the key word that lets us know what the heck we're doing in this sentence? Hopefully you saw the subtle keyword of of. Of means we're doing a given, right? There's a line there. And whatever comes after the line is the thing we know. So of adopted dogs. So if we had all the adopted dogs, it's very likely that this dog is a mutt. Oops, I wanted to use my blue. All right, 65%, whole new sentence. It just says mutts, nothing about adopted or not. And then the very end here, what is the probability that a randomly selected dog will be adopted and a mutt? So if you translated that 78 incorrectly, hopefully you would recognize it here because we have our and finally. So this is where we're going to use this formula. So if we use the formula verbatim, right, we see A is A, B is now M. So let's change all of the B's to M's. And hopefully a couple of you are yelling at your screen saying, lady, that's not good because this is written in the wrong direction. We can't use it there. And the question is, can we use it? The answer is no. So it turns out that this formula will not help us. Oops, I meant to use my red. The reason it won't help us right now is because I don't have that conditional conditioned on mutts. I have it conditioned on adopted. And the things that don't matter, and or, the order doesn't matter. Think about your Venn diagram, right? If we have a Venn diagram with an A and a B circle, and is just this middle section, and or is all the circles. So it doesn't matter which one I say first because they're the same regardless. So mutt and adopted is the same as adopted and a mutt. So it doesn't matter the order, so I might as well choose the one I have to write my formula. So M given A instead. And then I just need to be careful with my formula up above. Whatever was behind the line is the thing I multiplied by. So in my version, I make sure I multiply by adopted. That way, what was behind the line matches my marginal probability. So I'm going to replace those with those two different numbers, 0.78 times 0.6, which gives me some value, and I didn't bring a calculator with me, 0.468. So a most common error, if I had let you guys just tackle this question on your own, one of the most common errors is to just see this and probability. Oops, that's not my highlighter. See this and probability and just multiply A and M together because that's how we get and if they're independent. But if you haven't seen that keyword of independent, absolutely do not do that.